Chapter 6.6, use proportionality theorems. Okay, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So we have a triangle here, and we have two parallel lines. And that parallel line divides the sides proportionally. So RT over TQ, or this side divided by this side, equals RU over US. This side divided by that side. All right, and the converse of that theorem, the converse just means you reverse the if and the then statement. You reverse the first and second parts of the theorem. So it's almost the opposite. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. So they're saying if RT divided by TQ, that is this divided by that, equals RU over US, this divided by that, then those two lines are parallel. So TU is going to be parallel to QS. Example 1 in the diagram, QS is parallel to UT, RS is 4, ST is 6, QU is 9. What is the length of RQ? Let's take a look. Okay, so notice we have two sides parallel here. This is parallel to this side here, and we can call this length right here X. All right. So since these sides are parallel, we can say X divided by 9 is going to equal 4 divided by 6. Okay, notice I went the same way with the arrows in both cases. And now you can multiply both sides by 9, or you can cross multiply. X times 6 equals 9 times 4. And dividing both sides by 6. This is 36 divided by 6. That's just 6. Okay, and we let X represent QR, so QR is 6. Okay, the two theorems also tell you that if the lines are not parallel, then the proportion is not true, and vice versa. So here, in the first part of the statement, it says if the lines are not parallel, then the proportion is not true. And the vice versa is also true. If the proportion is not true, then the lines are not parallel. Example 2, on the shoe rack shown, AB is 33, BC is 27, CD 44, DE 25. Explain why the gray shelf is not parallel to the floor. All right, I'm going to have to label these side lengths. Okay, all of these units were in centimeters. So it said CB is 27, BA is 33, CD is 44, and DE is 25. Okay, so let's see if we can prove the proportion is equal. All right, so I am going to do 27 divided by 33 and see if that equals this right here, which is 44, divided by this right here, which is 25. Okay, and without even using the calculator or cross multiply, I can already see they're not equal. This is clearly less than 1, and this is clearly greater than 1. Okay, I'll do it on the calculator real quick just to prove it to you, but we can clearly see they are not equal. For this one, I got 0.82. For this one, 1.76. Those are not equal. Okay. And alternatively, you can cross multiply and see if those are equal. If you didn't want to do the decimals, it's the same amount of work either way. But because these are not proportional, that means that this side here, BD, is not parallel to AE. So the answer here is no, and BD is not parallel to AE. Let me just see how to make this symbol. Yeah, so I guess basically you would just cross out the parallel lines, or you would just say not parallel. Okay, please pause and try guided practice number 1. See if you can find the length of YZ. That is that measurement right there. Okay, pretty simple because these lines are parallel. We can do 44 divided by 35. And I want to go the same way on the other side, 36 divided by X. By the way, you can also go the other way as well, but you want to do both sides the same way. Okay, cross multiply 44 times X. And that equals 35 times 36. All right, and dividing both sides by 44 in order to solve for X. Cancels here. I'm going to do this on the calculator. All right, and I get a big decimal here. I get 28.636. So this is approximately 28.636. Okay, I think 2 decimal places. I'll do 1 decimal place here. So if you look at the second decimal, it's less than 5. So if it's less than 5, you round this down, and that'll keep it at 28.6. So this length right here would be 28.6. And that makes sense. I mean, this one here is less than 44, so this one would be less than 36. Okay, please try number 2. Determine whether PS is parallel to QR. So do the proportion and see if they are equal. Okay, so we're trying to prove this parallel to this. We want to write these proportions. Again, you can go either way, as long as you do it the same way both times. Okay, so I'm going to do 90 divided by 50. And see if that equals 72 divided by 40. Okay, on this one here, it looks like we can reduce fractions. These are both divisible by 10. Okay, so 90 divided by 10 is 9. 50 divided by 10 is 5. These are both divisible by 8. 72 divided by 8 is 9. 40 divided by 8 is 5. So 9/5 equals 9/5. So the answer here is yes, and PS is going to be parallel to QR. So this is true. Theorem 6.6, if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So remember, the transversal is the line that intersects 2 or more lines. It's basically the line that cuts through the parallel line. So this is a transversal right here. And this line here cutting the parallel lines is also a transversal. Since these 3 lines are all parallel, it divides these 3 lines proportionally. Okay, so UW divided by WY, in other words, this divided by that is going to equal VX over XZ. this divided by that. Theorem 6.7, if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the two other sides. Okay, so here's the triangle. This red thing here is the ray, and it's bisecting this angle C right here. You can see this angle is marked congruent to that angle. As a result, AD over DB, which means this over this, is going to equal CA over CB, this over this. Okay? You can also do it a different way. The way I like to remember it is more along the lines of this divided by that, so that's going to be CA over AD. And that's going to equal this divided by that. So that's going to be CB over BD. So I like to remember it that way instead. And just to prove to you it's the same, cross multiply AD times CB is going to equal DB times CA. Okay, and up here, CA times BD is going to equal AD times CB. Okay, so this matches that, and this one matches this one. So the way I did it is really the same, and I think it's easier to remember to do this side divided by that, and then this side divided by that. But this angle here has to be bisected in order for it to work. Example 3 in the diagram, angles 1, 2, and 3 are all congruent. GF is 120, D is 150, CD 300. Find the distance HF between Main and South Main. Let's see. Okay, so these angles are marked congruent. 1, 2, and 3. They are congruent. And it says that 120, 150, and 300. Okay, those are all marked on the diagram. And they want us to find the distance HF. Okay, so we are going from H to F. Okay, this whole thing right here. So we basically need this piece right here. So I am going to label this piece X. Now, they made a little mistake in this problem. They were supposed to tell us that these streets are all parallel. Okay, so this street on the bottom is parallel to this street, and the middle is parallel to that street on the top. All right, they should have mentioned that. And since these are all parallel, that means it cuts this line and this line proportionally. All right, so we can just write a proportion with two fractions. Okay, I'm going to do this line first. So let's do 120 divided by X. And the other street, you want to do the same way. We're going to do 150 divided by 300. Okay, I can do it in my head since 300 is 2 times 150. X is going to be 2 times 120, which is 240. All right, let's go through the process anyhow. Cross multiply X times 150. And that's going to equal 120 times 300. Okay, solving for X, the opposite of times 150 is divided by 150. Okay, and of course it cancels here. We're left with X. 300 divided by 150 is just 2. 120 times 2 is going to be 240. So that is not the final answer. That's just X, which is 240. But they wanted FH, the distance all the way from F to H. So we have to add 120 plus 240. So FH is going to be 120 plus 240. And that equals 360. Okay, the units were all in yards. So these units on the answer are also going to be in yards, YDS. All right, in the diagram, example 4, in the diagram, QPR, angle QPR is angle RPS. Use the side lanes to find RS. Let's see. Okay, right here, QPR is this one, and SPR is this one. So since this angle is bisected, we can make this proportional. Now, we need this piece right here. We see this one right here is X, and the whole thing is 15. So what do you think the length of this is going to equal? Well, that's just 15 minus X. Okay, so right here, I'm going to write 15 minus X. All right, and that is just that piece right there. Now, since this angle is bisected, we can do the proportion. Okay, start on the left. I'm going to do 7 divided by 15 minus X. And on the right, I'm going to do this piece right here is just X. So on the right, it's just going to be 13 divided by X. All right, cross multiply. 7 times X. And that's going to equal, you need parentheses here, 15 minus X times 13. Okay, 7X. Distributing, 13 times negative X is negative 13X. 13 times 15, that's going to be 130 plus 65. I think that is 295. All right, I'm going to check real quick. Okay, it's actually 195. 13 times 15. Solving for X, we want to get the X's on the left. So we're left with this number here by itself. Opposite of negative 13, X is positive 13X. Do it to both sides. 7 plus 13 is 20, and that has an X on it. Bring down the equals. Negative 13 plus 13 is gone. Bring down the 195. Okay, and dividing both sides by 20. It cancels here. And let's see. You can do it on the calculator. I'm going to see if I can get this. The bottom divided by 5 is 4. 5 into 19 goes 3 times. And carry the 4. 5 into 45 goes 9 times. So that should be correct, 39 over 4. If you want a decimal, let me do that real quick. I think that's going to be 9.75. Let me double check. Yes, that's correct. 9.75 is the value for X. All right, I reduced it, but if you can't, then just do that on the calculator. Now let me see if that's what they asked for. They asked for RS, and we said RS was X. So RS is 9.75. Okay, please try guided practice number 3. I'll give you a hint. 2 hints. First off, you want to call this X. And secondly, since these 3 lines here make right angles all with this same line, They all make right angles. That means they're all parallel. Since they make right angles with the same line, all three of those are parallel. So see if you can solve for x, please. Round off if you need to. All right, let's do them both the same way. We're going to do 16 divided by x. And that's going to equal 15 divided by 18. Cross multiply 16 times 18. And that equals x times 15. Okay, divide both sides by 15. Cancels here. Let's see what we can do with this before the calculator. 18 divided by 3 is 6. 15 divided by 3 is 5. 16 times 6 is 96 over 5. I'll do the calculator here. I think it's going to be 19.2. Let me double check on the calculator. Yes, it's 19.2. So this right here is 19.2. Does the answer make sense? Well, 18 is more than 15, so 19.2 is going to be more than 18. Okay, since 16 is more than 15, this should be a little more than 18. Okay, please try this one here. I changed their numbers around, but I marked this angle congruent to that angle, and we want to solve for AB. We'll just call that X. Please try it. All right, since this angle is bisected, we can do 5 divided by 4. And that's going to equal X divided by 3. Okay, notice I went the same way on both sides, on both triangles. Cross multiply 5 times 3 is going to equal 4 times X. The opposite of times 4 is divided by 4. And this is going to be 15/4. If you want a decimal, that's going to be 3.75. Does the answer make sense? Well, let's see. 4 is more than 3, or I should say 3 is less than 4, so this should be less than 5. So yeah, it makes sense.